In this video, we'll talk about two types of random variables. The two types are discrete and continuous random variables. We will also learn that many types of numerical data are observed values of discrete random variables. Our first important term is the random variable. The random variable is a variable that assumes numerical values associated with the random outcomes of an experiment, where one and only one numerical value is assigned to each sample point. The next term is countable. To be countable, the values of a random variable x can be listed even if the list is never ending. Discrete is our next term. A discrete random variable is one that can assume a countable number of values. Discrete random variable is a finite number of distinct possible values. Continuous refers to random variables that can assume values corresponding to any of the points contained in an interval, such as the fractions or decimals that fall between integers or are counting numbers. Continuous random variable is the final term, and we have a continuous random variable when the values of a random variable are not countable, but instead correspond to the points on some interval. And those include our measurements such as time, length, width, height, area, volume, distance, perimeter, and so on. All of these measurements are included with continuous random variables, because something like time is not always measured in whole hours. It is including half hours, quarter of an hour, minutes, seconds, milliseconds. So those are all of the measurements in between the interval of 1 hour to 2 hours to 3 hours. So time and length, width, those kind of measurements, also with length, width, height. It's not just feet or meters, it's all of the increments that are between those integers associated with whole amounts. So we're going to look at an example to illustrate the difference between discrete and continuous random variables. The first reference for classwork today involves statistical literacy. Which of the following are continuous variables and which are discrete? Example A is talking about the number of students enrolled at ENMU. Since this involves people, we know that counting those people involves only integers. So the number of students is a count, and that would be an example of a discrete random variable. Example B is talking about the distance between Clovis and Portales. Distance between Clovis and Portales could be measured in miles, and it is possible to be at increments in between intervals for miles, such as half mile or feet, inches. So distance falls under the continuous category. So we have a continuous random variable. Example C is talking about time required to complete an exam. So if we think about time, we might think about hours, increments in between hours like half hours or minutes. That would make sense for this example of completing an exam. It's not necessarily true that you complete exactly in 1 hour or 2 hours. So time is going to be another example of continuous random variable. So example D is number of students, and since students involves people, we're not going to have increments between people. So number of students is an example of a discrete random variable. Our final example is your weight before you start college. So weight, you could think of pounds, half pounds, ounces. So weight is going to have increments between the intervals that would make sense for the weight of a person. So weight is another example of a measurement, which is a continuous random variable. So you might find it helpful when you're reading the description. Ask yourself, is this describing a measurement or not a measurement? Typically, if it is a measurement, you're going to have a continuous random variable. And if it's not a measurement, oftentimes you will have a discrete random variable.